Thank you so much. Hi, everybody. Thank you so much for being here. We are so excited to be here in the beautiful Belgrade. My name is Michal.
I'm Vered.
And we come here from the Davidson Institute of Science Education, the educational arm of the Weizmann Institute of Science. And the Science Education is a non-profit organization promoting science and the cutting-edge science to every part of the population. And we're very, very excited to be here today.
Yes. And today we're going to play a bit with science and engineering. And we're going to look at nature from a scientific and an engineering kind of way. And the first thing that we want to do, we're going to look at nature. And we sit here at the bar, and you all have, I see drinks, you have beer, you have coffee, I see wine. And in Hebrew, when we drink something and we take our glasses up high in the air, and we say L'chaim, and in Serbian you say?
Shivali.
So I want you to raise your hands with your drinks and say Shivali.
L'chaim.
I want you to notice how you hold your drink. How many fingers do you use? Just notice. Do you use one finger, two, all five? So, Shivali.
Shivali, L'chaim. Okay. So, as you probably imagined, Vered and I are a big fan of nature.
Yes, very keen.
Big fan of nature. And there's nothing more amazing in nature. There's nothing wilder in nature than an elephant. And elephants are simply amazing in every possible way. And one of the best things about elephants, is their trunk. The trunk is an amazing organ. Anyone know what the trunk is used for? The trunk is an amazing organ for showering. Brilliant. What else? For drinking. Very important. But very important at the bar. But the trunk is an amazing organ of breathing, first of all. It's an organ for breathing, and it's also a hand-like organ for grabbing things and moving things around. Now, the elephant trunk has about 100,000 muscle fibers. 100,000 muscle fibers that helps him be such amazing with both fine and gross coordination, which means that he can grab small items like leaves or even small peanuts, or it can grab a full watermelon or a full big rock in the savannah.
Yeah.
But what I wanted to say next was, if you look at this picture, you can look at the tip of the elephant trunk, and you can see that the Asian elephant has only one finger at the end of his trunk. It can grab things like this. And the African elephant has two fingers at the end of the trunk. So he can grab things like this. Which one is better? The African one. The African with two fingers. Well, it's easier to catch glasses with two fingers at the end. But I think if I was an elephant well enough, I would be able to catch my glass like this as well. Meaning, it doesn't really matter. That's what evolution is all about. What works for you, just works.
You take care of this one, and I'll continue. So, as humans, we always try to build robots. And when we go and I say to you that I'm building a robot, most of the time you think about this robustic, made of metal, boxy thing, like... Let me see. Like?
מה קורה פה?
No. Like the thing that you needed to see right now. But...
Wow.
Yes. But when engineers went and wanted to build a robotic hand. So when you want to build a robotic hand, it's pretty simple because you need an arm. You need 5 fingers. In each finger, you need 3 joints. And the movement is pretty simple because you need only a robot that can do that. Great. And Bless you.
Yeah. All right.
Okay. So this is the robot you think of.
This is the robot.
This is the robotic hand, and it's pretty simple. Now, when we build robots, we want to build machines that can do things that we cannot. That means that we wanted to be able to handle things even the most qualified human hand cannot handle. So when the engineers of FESTO Robotic Engineering wanted to build a robotic hand, they didn't go for the bionic hand that is pretty simple and can only do that. They built a bionic handling assistant that is inspired by the elephant's trunk. And this robot that is inspired by an elephant trunk is used in the industry for things that are pretty delicate, like attaching fibers, very, very delicate fibers into stuff like in toothbrushes. They attach the very delicate fibers to the plastic. It's also being used in the
medical industry.
The medical industry
Very
and
fine.
in the car industry.
With very massive, very gross mechanism.
Grass and fine mechanisms.
Yeah. So now let's ask you a question. Now that you know a bit more about elephant trunk and bionic trunk, what would you do if you had a bionic elephant trunk at home? What would it be used for?
Besides drinking from afar and not
or just bringing the drink from far instead of calling someone to bring it from...
Besides that.
Besides that, of course. Think for shower. Well, that's a good idea. Yeah. That's a good question. And more than that, because of the next thing that we're going to talk about. But as we said before, the trunk is an amazing organ, and it is used for many things. So we said it's a breathing organ, and we said it's a hand-like organ, but it's also an amazing straw. Mm-hmm. When an African elephant wants to take a sip from his beer or coffee, he can take approximately 10 liters of liquid in his trunk in every sip. That's quite a lot. Now, if we want to be inspired by elephant and we want to invent new things inspired by elephant, we need to feel like an elephant. We need to, in order to think like an elephant, we need to feel like an elephant. So that's when we ask you, is anyone able to drink like an elephant?
She owes us.
I think she owes us. She made us.
Go, come.
Yeah.
So what we want you to do is to try and lift liquids using this. No, not with your nose. It's okay. Just
not through your nose.
Through your straw. But you need a really, really good set of lungs now. You need to be like an elephant. So you need to pull all this liquid up and try. Yeah.
It's about 2 meters of a straw, and the trunk is about 2.5 meters. No, it's not 2 meters. It's 1.5 meters. Yes, it's been done.
Lana's boy.
Yeah.
2 days ago. Okay.
So it's going up.
Why is it difficult?
Going up, going up, going up, going up. No. One more time. Going up, going up, going up. But stays. What? It's over here. It's about. You're doing it. You managed. Yay!
Very good.
Almost a brilliant elephant.
Thank you so much.
Thank you so much. Yeah, being an elephant is harder than it looks. Oh, yeah. You really do need a good set of lungs in order to lift liquids to highest high, which leads us to the next animal that we want to talk about, which also needs to lift liquids to high levels.
Yes.
Which organism is that? Well, you know that.
Yeah. This is the giraffe. And the giraffe, if you look at the giraffe from a scientific and an engineering perspective, it is an impossible animal. It's too high, it's too thin, it's not really balanced on this thin leg of hers, and it has to pump blood all the way, 2 meters high, 3 meters down, the heart is in the middle, and it's really hard because the blood pressure might be too high for the brain, but it has to defy gravity and come all the way from the ground, and it needs a really, really big heart. Now,
and it has to do all that without being eaten by a lion.
Yeah, and it has to stay balanced while eating, mating, fighting other predators, and not being eaten by lions. So it's fairly impossible, only it exists. We have giraffes. So what's the story with the giraffe?
So when we think bio-inspired or bio-inspiration, we are always looking for adaptation, for evolutionary adaptation. And one of the best phenomena, or one of the best adaptation that giraffes has is their blood circularity. The blood circularity of the giraffe has to take the blood from the heart, going up about 2.5, 3 meters, and then going down to the legs, which means that they must have a huge, very massive heart, about this big.
It's a 6 to 8 kilograms. It's about 40 centimeters long. It's pretty big heart.
So let's try to see how that works.
Yes.
We actually brought here a giraffe's heart. Well, it's not really a giraffe's heart. It's a bag full of giraffe's blood. Well, not actually a giraffe's blood, but
it's cherry juice.
It's cherry juice.
Yes.
But it does have about 2.5 meters of a tube, which is about the height of the giraffe from his heart to the end of his brain, to the head. So we were wondering, maybe anyone here feels like being a giraffe for a day. Come on, give her a hand. She really needs it. Yes. Oh no, she has a
white skirt. Okay, you'll be
over
there.
I will pray.
No, over there.
No, you come here, and you're gonna be the heart. So
yeah,
you are pumping, and I just need to press this once, and you need to bring the blood all the way up so Vered can put it in the glass. All right?
Can I start?
Yes.
Yes. You need to pump it really hard.
Very, very hot. Ah, wait, I need to... Maybe if I'll open it. Okay, so it's going up here.
Yay!
Yeah. Doing more. Going a bit, but you need to pump much more. You need to pump quite fast.
Almost.
Almost, yeah. Yeah, you can do it, you can do it. It's not that easy being a giraffe, eh? It's not that easy. There is just a few drops of blood in the glass, or of juice, of course.
Yes.
It wasn't easy.
No, it wasn't.
No.
Okay. Thank you very much for definitely trying. But yes, being a giraffe is definitely hard. Taking the blood.
And the real challenge with the giraffe is it needs adaptation to deal with all the pressure needed to bring the blood up back to the heart, because there's gravity that pulls all the blood down to the ground. So one of the most amazing adaptations of the giraffe, that the skin on her legs is so tight, so it applies an outer pressure on the veins so the blood can go back up. And this was inspiring for an amazing and different kind of industry, which is the space textile industry, which is not yet an industry, but yet.
Who knows?
Who knows?
Who knows? So Professor Deva Newman from MIT and NASA, she was inspired by the giraffe legs, the adaptation from the giraffe legs, which have a very, very tight skin that is pressing the blood vessels and all the circularity system on the legs so it can lift back the blood up. She was inspired by that in order to build a new astronaut spacesuit, which the textile actually reflects with the pressure outside, the pressure out in space. It actually reacts to the pressure.
Back in the days, when there was not such an amazing suit, the astronauts had to adapt the pressure inside their suits so they stay healthy, they won't get damaged. But now, because of this textile, they don't need to play with the suit anymore, and it does it for them.
Exactly, because being in space has enough pressure on the astronauts as it is, and they need to handle so many things. So taking care of their own health, that's one thing too much. And if the spacesuit will react to the environment, that will take one thing less from them, one thing off. Yeah.
Now, when we looked at a giraffe and we looked at the elephant, the problem seemed really obvious. But some of the problems are not that obvious, and sometimes the solutions are invisible. So what we have here, I have here 2 glasses, and I have a riddle for you. Because in one of them, I have soda water, like sparkling water, and the other has tonic water, and I have no idea which is which. Can you tell me, without tasting it, which solution is sparkling water and which is tonic water? Can you tell?
We actually lost count. We have no idea which is which.
Can you tell? Can any of you tell? Now I can give you a hint. If we had a falcon, like a bird, in this audience, he would know. Can you tell? Which is which? Any idea?
So let's try to find out.
Yes.
We have a system. Well, we can drink them and then find out.
No, we cannot drink them. No. But we have flashlights, UV, ultraviolet flashlights, and let's see what happens to the different solutions if we apply ultraviolet light. Ready? Hang on. Hop. Which is which? Any idea? Now, plain water is just plain water, soda water. It doesn't do anything with the ultraviolet light. But the tonic water has inside a substance called quinine. And quinine absorbs UV light and reacts to it and it creates this amazing glowing blue. So I can tell by using a light, ultraviolet light, which solution is which. Now I told you that birds can actually see the colors. And I have here another animal that reacts to ultraviolet light. Which animal is that?
Yeah.
A scorpion. Okay? So when we go camping in Israel, usually we take our UV light, ultraviolet light, flashlight, because all scorpions in nature, each and every one of them, glows under UV light. Why? Any idea? Well, we don't know. But
look, you can have a wild guess because we're talking about wildlife.
You can assume. We assume that that is because birds, as we said, can see this UV light. And maybe the scorpions, that's their way to show the birds, hey, I'm really dangerous, don't mess with me. And that's the way the birds of prey don't mess with the scorpions. Now, some animals do see UV light, some animals glow under UV light, and birds not only use this vision to stay away from scorpions, they also use this special eyesight to locate urine of rodents. Because urine of rodents like mice and like
different rodents,
small rodents,
rats, even.
Their urine reflects UV light, and that's the way the birds of prey locate their prey.
By the way, if you have mice problem at home or at the office, that's also another way to try to locate them or where they sleep, just with the UV light. So we already know that some birds see UV light and they can locate their prey, or they can detect dangerous things. But that gave an inspiration, that inspired one of the most amazing bio-inspired design for solution to one of the world's biggest design challenges or problem, which is birds crashing into windows. Now, that might sound silly, but did any of you ever sat in your saloon or at the office and then a bird just crashed in the window? That ever happened to you? It happened. In Israel, we get quite a lot of migrating birds, and at home, it happened to me quite a lot. That birds just crashed into the window. And it sounds silly, and it sounds like something that happens once a while, but apparently, there are just about 250,000 birds losing their life and dying every day by crashing into windows. Now, that's a design problem. That is a design challenge because we are building our buildings very high. We are building them with lots of windows, and birds don't see those windows. They see what is reflected behind them, which is the sky, and then they just fly in them. That's a design problem. So a glass company called Arnold Glass tried to solve this problem. And what did they do? They tried to find what birds don't crash into. And what do birds don't crash in? Apparently, on trees. Well, they thought about trees, but they found it a bit problematic to put a tree on every window. But what they did find, and I have to say I was so surprised, they did find that birds don't crash into spider webs, because apparently spider webs are UV reflected as well. And what we see as sort of like a gray, white, very, very nasty color, the birds see as a beautiful ultraviolet color, and they just don't go into the spider webs.
Maybe like this.
Maybe like this. That's quite beautiful, I have to say. So what they did in this glass company, they took windows and they painted on it with UV light, which means that we cannot see the reflection, but birds can.
So the window stays clear, so the sun can go in. It doesn't affect the way you see the outside, but birds don't crash.
Let's try to see if I can show you that. No, it won't work.
They can't even
But
see.
you are more than welcome to come afterwards and have a look at those windows. Because if we turn them around, then we can see the web. But if we just look at them, they look quite clear. So that company actually learned from nature in order to protect nature and save nature. And that is probably the most brilliant thing.
Yeah, and I also have here, would you like to write a simple message, like with this invisible pen? Go ahead. I have here an invisible pen, and I want Lana here.
Lana, can you show them that there's nothing on the page that we didn't do it before?
I feel like a magician.
Yeah.
Yeah.
We are sort of a magician because science is magical.
Okay.
Simple message.
Wow,
Very
message.
simple.
She's writing like the entire, a brief. Thank you so much. So, can you read it? Sir, can you read what's... Really? I don't know him, so it's okay.
All
Okay,
right.
now, go ahead.
Let's have a look. Can you help us? Can you read what's in here? No. Okay. But if I'll do that. We are happy to have you in Belgrade. Well, I'll come to the back. Can you see this? No? No one? Really? You sure? Okay. And what about now? Can you see? All right. Great.
Thank you.
Thanks,
Thank you,
Lana.
Lana. That's a great way also to hidden messages. Okay. So another thing that is really important in nature is balance. It's also important in life as well for us as humans. But to animals, it's pretty important because if you can balance yourself on surfaces that other creatures cannot, you have an advantage. Okay? So, but not all animals have it that easy. This animal, tiny, tiny animal that sits on a coin, it's called the pumpkin frog. It's a pumpkin frog because it's orange and it's tiny. That's all the size. And she pays a really big price for being so tiny because the balance organ in its ear is so small that it doesn't function anymore. So what it does, it jumps and it crashes into surfaces. But as we say in evolution, if it's good enough, then it's the best. So it doesn't really work, but it works. So in evolution, it's the best solution because it just works.
Well, that's what evolution is all about.
Yeah.
So here's another animal that needs to keep balance, but they do it a bit better, just a bit. This is the sifaka. Sifaka is a kind of lemur coming from Madagascar. But the sifaka, it can't really walk straight. It has a bit of a different mechanisms. It can't walk straight, just like some of the people we met today after drinking 4 rakias, yeah? Can't really walk straight. But what it can do, not like those people that we met today, not to say any names. What it can do is jump. And when he wants to cross from one tree to another, he just lifts his hand up and jump to the side to keep the balance. Now, it might look stupid, but it works. And that's what evolution is all about.
Yeah.
And there's another animal that needs to keep balance in a quite a weird and unique kind of way. This is the toucan. The toucan is an amazing bird coming from South America, sorry. South America. And if you look at the beak size is about a third long from the whole length of her body, which means that if we'll think about it, it was supposed to fall down to the front all the time.
You have a nose. This is a third of your body.
Yep. So it needs to fall to the front all the time. It definitely can't fly because its beak is too long. But it can fly, and it does fly. And not only that it flies, it can also stand on the tree and eat fruits from another branch, and all that with the beak. And how does it do that? It does that with a special kind of structure that lets him, because the beak is filled with air, and the air gives it both strength and lightweight, which means it can fly, and it can do a lot of other things, because that's evolution, and that's how it works. So let's play.
Yeah, another game. So when we talk about balance, it's all about a point that is called the center of mass. Now, every object has this point that is the center of mass. And if I will ask you to grab something for a table, a fork or something, and put it on your finger, would you like to try? Please, come here. I want you to take the fork and balance it on your finger. No? It's quite easy. Okay, someone else? Be brave.
Oh, yay! Thank you.
Thank you.
She was the bravest one in the room.
Great. Come here. Now, I want you to balance this fork on your finger. I'm not telling you where. Just try.
Yeah, it was quite easy.
Thank you so much. Now, it was pretty simple and pretty intuitive because, you see there's a bigger size over here, it's a bit delicate over here, and I saw that you calculated, did it in your head, and then just felt it. And every object has this center of mass thing. Now, I want you to guess where the center of mass of this can is. It's a simple object.
I think you should probably take it to that table over there so they can all see that.
There.
Yeah? Is it okay?
On your table? It's okay. So, what I'm going to do, this can is a magic can, and if you have cans on your tables, I'm just going to put it on its side. Ta-da! Okay. Do you have cans? Do you have bottles? Do you have something that you can put on the side? Can you do that? I'm scaring you, sorry. So, okay.
Vered, why don't we try it here
we'll
now?
try it over here. I'm going to put this can on its side. And it's not a magic can, it's just a simple can from the supermarket. Okay. How did I do that? So, I'm telling you, it's a secret. Every object, we said, has a center of mass. And if this can was full, the center of mass of this can, which is a very simple object, would be in the center of this can. But if I put it on its side, when it is full, the center of mass will not be supported because it will be in the air. But if I put the right amount of water, which for this size of can is exactly 100 milliliters, the center of mass goes down, just like the toucans. And when the center of mass is lower, and I put it on the side, it sits just above the point where I put it on the ground. So it stays stable. Okay? So this is not magic. This is just physics.
So we're getting closer to the end of this talk, which means that we probably should tell you by now, what are we talking about for the past few minutes? Well, we're talking about a discipline called biomimicry or bioinspiration. Bioinspiration is an interdisciplinary methodology in which biological and ecological principles are applied to problem solving in sustainable development. Animals and plants adaptation, biological forms, mechanisms, functions, processes are giving us a library of inspiration to create innovative, sustainable solutions in different fields. Bioinspiration happens when you take wildlife, you learn about wildlife, and you think about it as wild science. And wild science leads us to wild ideas and wild innovation and inspiration. Now, the real question is, in a few minutes, or when you finish your drinks, and you go out back to the amazing nature of Belgrade, what are you going to do with all this information? What's going to be your next big inspiration and maybe innovation inspired by nature? So thank you very much for being with us and listening.
Thank you.
Thank you. And we have a few minutes for questions? Yes. Okay. So we have a few minutes for questions.
Hi, and thank you for your interesting talk. My question is not related to the scientific part, but to the science promotion and science popularization. So I would like to ask you, what would you advise to young researchers? I guess there are more of those in the audience as I am. How can we contribute to that part? And my second question is how to multitask between the research and science popularization. Thank you.
Good question.
Brilliant question.
I think that as a young scientist, you're very passionate about what you do. And I think the best thing for a young kid to see is someone is very passionate about what he's doing, and the best teachers are the ones that are very passionate. Because if you see a tired teacher that is already does the same every day, it reflects on the kid. So as a student, when you have all this love for what you do, I tell, go, teach. Because as a scientist, there's nothing you love more than to tell people about what you do, right? You just want to tell them and make them inspire them and make them love this field. So it's hard to do both, but it fills you, because when you teach, it gives back. It's not just giving to the society, it gives it to yourself. So that's my advice.
Questions? No? Okay. Zamolit ću profesora Vladimira Đurđevića. You're done? Okay, yeah. No more questions? Okay, we want to thank you.
Thank you.
Thank you so much.
We'll be here if anyone remembers something. We're here and feel free to contact us in person.
Thank you.